Today we are going to work on 2-5 notes. I know that you're all sad that I'm gone. As I told you yesterday, I am in Bloomington, moving my daughter to IU. Hopefully you have read section 2.5 and done the vocab so that you're ready to jump in and understand what I'm talking about today. The 5-number summary is the first thing I want to talk about. There's 5 pieces to that, obviously. The minimum entry, the first quartile, which is Q1, and about 1/4 of the data falls on or below this point. The median, Q2, about 1/2 of the data fall on or below this point. Q3, which is the third quartile, about 3/4 of the data fall on or below this point, and then the maximum entry. We also have the interquartile range, which is the middle 50% of the data, and you find that by taking Q3 minus Q1. We're going to use the 5-number summary to create a box and whisker plot. The guidelines are here, and I will go through them as we create the box and whiskers plot for the example that I have. The example says use the final combined scores from the Little League World Series Championship to draw a box and whiskers plot. So this is the combined championship score from the last 20 years, okay? And I've asterisked one because it's kind of an exciting one. Back in 2002, Valley Station was the Little League World Championship. They beat Japan 1-0, so their combined score was obviously 1. So that's where these numbers came from. Since it's Little League World Series time, I thought that might be kind of fun. First thing you want to do is you want to rewrite the data in order, being really careful not to miss any. 1, there are 2, 3 threes. There are 1, 2, 3, 4 fives. 1, 2, 3, 4 fives. No 6, no 7s. If I happen to miss one, I'll come back and pick it up, but I'm going to try and be careful not to miss any. 9, 9, 10, 11, 12, 13, 2 13s, 14, 16. Let's see if I can move these over a little bit. It'd be easier if we can put them all in a row. I know you wish you could do that. 20 and 21. Okay, because you want it, like I said, much easier if they're all in the same row here. Okay, so we want to go back and we want to find the quartiles. Okay, we have to find the 5-number summary, and the quartiles are part of that. Easiest way to do that is to find the median first. Okay, you want to find the median. We talked about that in one of the previous sections. Since there are 20 pieces of data, there's not a true median, so you want to go to the middle 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 10 and 11 are going to be the middle 2. You can always use, where you can count inward to find that as well. The 1 and the 21 match, the 3 and the 20, the 3 and the 16, the 3 and the 14, 5 and the 13, and so on. So to find the median, you're going to take 9 plus 9 divided by 2, which is obviously 9. So my median is 9. That's also considered Q2. Sorry, I accidentally wrote Q3. It's also considered Q2, and it's 9. Now, to find Q1, you look to the right of what you want to do is you want to cover up the right side, and you want to look to the left of that median. And then you want to find the median of that data. So just to recap there, you find the median, look for the middle number of all the data, then you want to look to the left of it, so you want to cover up the right, and you want to find the median of that. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data there. So again, I'm going to have to add the fifth and the sixth, divide by 2, and Q1 is 5. To find Q3, we want to cover up the other side, so I'm going to cover up the left side, everything to the left of the median, and I'm going to look for the median of the right side of the data. Again, there should be 10 pieces, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to look at the fifth and the sixth. Purely coincidence that they happen to be the same number. Lots of times you'll get a decimal or something different. So this is kind of just a weird example. That's the way it turned out. Get rid of my curtain here. So Q3 is 13. The minimum should be obvious since they're in order. It's 1. The maximum should be obvious since they're in order. It's 21. So there's my 5-number summary set. Everything I'm going to need to draw my box and whiskers. Okay, so that's step 1, finding the box and whiskers. Find the 5-number summary set. Next thing it says to do is construct a horizontal scale that spans the range of the data. I have a minimum of 1 and a maximum of 21. So when I draw my number line, I need to span that far. So I'm going to go from 0, and I'm going to go by 2s. Your scale's kind of your preference. And that's far enough. I just needed to get as far as 21. You're going to plot the 5 numbers above the horizontal line, above your number line that you just drew. So above the number line, I'm going to put my minimum of 1, Q1 of 5, Q2 of 9, Q3 is 13, and then the max is 21. You draw a box above the horizontal scale from Q1 to Q3. You draw a vertical line through Q2, and then you draw whiskers to the max and the min. So there's my box and whisker. The interesting thing about a box and whisker is it divides the data into fourths, so it makes it really easy to talk about. So about 25% of the World Series games had between 1 and 5 total combined runs. About 25% had between 13 and 21 combined runs. Then the box itself gives you that middle data. So about 50% of the games had between 5 and 13 combined runs. So you can see a lot and read a lot from a box and whiskers plot. The next thing we want to talk about is a z-score. A z-score is the number of standard deviations a given value x falls from the mean mu. The formula is z equals the value minus the mean divided by the standard deviation. In symbols, that's x minus mu over sigma. A value that is above the mean is going to have a positive z-score, and a value that is below the mean is going to have a negative z-score. And z-scores match up to those standard deviations that we talked about yesterday on the bell curve, and we'll pull that all together in the next lesson. Today we're just really introducing z-scores. It says the average height of a woman is 65 inches with a standard deviation of 3.5 inches, and the average height of a man is 70 inches with a standard deviation of 4 inches. Find the z-score that corresponds to the following heights and determine if they are unusual. So for the first one, let's pull out all this information, and this is a female, so I'm going to look for that female information. It says the mean is 65, the standard deviation is 3.5, and for this particular example, my person is 68 inches, so my x is 68 inches. So I'm going to use the formula and say 68 minus the mean divided by 3.5. And you can get your calculator out. 68 minus 65. Either make sure you put those in parentheses or hit enter, divided by 3.5. And this person is 0.857. So almost one standard deviation above the mean, which makes sense because they are taller, so I should have a positive standard deviation. And so this just kind of tells you where you fall on that normal curve. You're almost one standard deviation away. Let's do a male that's 68 inches. So we need that information about males. The mean height of males is 70. The standard deviation is 4. And the x value for this one is 68. So the same height, but let's see how this falls in comparison to other men. Z is 68 minus 70 over 4. So that's negative 2 over 4, which is negative 1/2, or negative 0.5. So about a half of a standard deviation below the mean, which again makes sense. We talked again yesterday about being unusual. Anything more than 2 or 3 standard deviations away is going to be really unusual. So these first two people, pretty normal. The female, a little above average, nothing unusual. The male, a little below average, nothing too unusual. There are 2 more on here. I'm going to give you about a minute or 2 to figure these out, and then we'll come back together. Your height obviously is going to be different for everyone, but we'll talk about it and make sure you understand. So I'll give you just about a minute to see if you can figure those out. Okay, should have had time to get this done. For the female, we're going to go back to the female data. So x would be 61 here. So you're going to take 61 minus the mean, which was 65, divided by the standard deviation. So this is negative 4 over 3.5. If you want to get out your calculator and figure out what that is, negative 4 divided by 3.5 is negative 1.14. So this person was a little more than one standard deviation below the mean. This problem obviously is going to be different for everybody. I'll do it for my height. I'm 5'9", so 69 inches tall, minus the mean, divided by the standard deviation, which is going to be 4 divided by 3.5, which is going to give me a positive 1.14. So I'm a little bit more than one standard deviation above the mean when it comes to height. Homework for today is going to be page 107, 1 through 15 odd, 21, 31, 35, 39, 43, 47, and 49. So you have the rest of the period to work. I'll be back tomorrow in the morning. I do have a meeting tomorrow afternoon. We've got a test coming up, and this is the last section, so we'll start reviewing and doing some things to get you prepared for the test.